Hello, today we're going to take a look at reviewing how to find exact values for our sum and difference identities and our half-angle identities. So for our sum and difference, we can look at this to use this for our angles that are typically going to be our twelfths. Like for example, we've got our cosine of 11 pi over 12. The first thing we want to do is take a look at the angles that we typically use and know all the values for. So our pi over 4, pi over 6, I don't want to do those here. So pi over 6, pi over 4, pi over 3, and sometimes pi over 2. And rewrite those to all have the common denominator of twelfths. So pi over 6 is 2 pi over 12, pi over 4 is 3 pi over 12, and so on. Now, what we can do is take a look at these and try and write them as a sum or a difference of either two of these angles or multiples of these angles. So for example, if tangent of 5 pi over 12, we can rewrite that as tangent of 2 pi over 12 plus 3 pi over 12. Because then when we simplify that, this is just pi over 6 plus pi over 4. And then we'd use the formula, which we'll look at in a second. Other times, there's not one, like we can't look at these and go, oh, well, 6 plus 3 plus 2 is equal to 11 because we want to do this as a sum or difference of two angles. So we can look at, like, all right, well, what are some of our numbers that add up to 11 that are factors of 12? Either add to 11 or subtract. So we could do cosine of 9 pi over 12 plus 2 pi over 12. So we couldn't do like 6 pi over 12 and 5 pi over 12 because the 5 pi over 12 we don't know our angles for. Whereas 9 pi over 12 and 2 pi over 12, that will simplify to this is 3 pi over 4 and this is pi over 6. Now, we just take a look at our formulas. And so for our cosine, we've got the cosine of 3 pi over 4 plus pi over 6. For our cosine identity, right here, we just substitute these in. So it's cosine of the first angle, so cosine of 3 pi over 4, cosine of the second angle. And then the reason that this is minus or plus is because we change the sign. We also have the nice little alliteration that sine, it's the same, cosine you change. So this is plus, so this has to be minus. And then it's sine of 3 pi over 4, sine of pi over 6. All right, so cosine of 3 pi over 4 is negative square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. And all we're doing is just evaluating these angle measures, or trig functions. So sine of 3 pi over 4 is a positive square root of 2 over 2. Sine of pi over 6 is 1/2. And then we can combine these terms because we have a common denominator. And then this is our exact value for cosine of 11 pi over 12. Now tangent is going to work in a very similar fashion. It's just going to be a little bit different when we simplify it. So our tangent of pi over 6 plus pi over 4, our tangent formula is right over here. So it is the tangent of our first angle plus the tangent of our second angle divided by 1 minus tangent of the first angle, tangent of the second angle. Now, here, this sign is positive. Since tangent sine divided by cosine, it's the same sign divided by the changed sign. All right, tangent of pi over 6 is root 3 over 3. Tangent of pi over 4 is 1. Then we have 1 minus tangent of pi over 6 is still root 3 over 3 times 1. So what we're going to do here to simplify this is first, so that we're not working with fractions in fractions, although that's one way you could work with this, multiply this whole thing by 3/3, because then we'll end up with square root of 3 plus 3 over 3 minus the square root of 3, so that we're just dealing with radicals and one fraction. You could also find a common denominator in the numerator, combine them, common denominator in the denominator, combine them, and then you'd end up with this same thing after you multiplied by the reciprocal. But what we can do here is now multiply this, because we don't want that radical in the denominator, and multiply by 3 plus the square root of 3 divided by 3 plus the square root of 3, because that's the conjugate of the denominator. So what we'll end up with in the numerator, just FOIL. You know how to multiply binomials. So it'll be 3 root 3. Outer, so plus 3. Inner, plus 9. Last, plus 3 root 3. And then our denominator, when we multiply conjugates, we end up with a difference of perfect squares. So it'll be 3 squared minus square root of 3 squared. Now we do some simplifying. 3 root 3 plus 3 root 3 is 6 root 3. 3 plus 9 is 12. 9 minus 3 is 6. So now we can factor out a 6 from every term. So it's just square root of 3 plus 2. Okay? Now, sometimes we won't be looking for the exact value of something. We'll be given the expanded form of a sum or difference identity. So what we want to do here is take a look at this and see, all right, well, we have cosine, cosine, sine, sine. These are angles that we don't know the values for. So we look at our identities to see, all right, well, which one looks like cosine, cosine, sine, sine? And that's going to be our cosine identity. So what we can do is we know that it's going to be cosine. And this isn't us just going, oh, we're just looking at these. No, the entire thing is our cosine sum or difference identity. So our two angles are the two angles that show up in the problem. We're looking at this just like one of the identities, just we're starting with the expanded side and have to contract it. So we have 29 pi over 12, or sorry, 18, and then 4 pi over 9. Now, since it's the cosine identity, we have to change this sign. All right. We need a common denominator to combine these. So let's multiply this term by 2 halves. We're allowed to do that because it's a form of 1. So we have the cosine of 29 pi over 18 minus 8 pi over 18. We'll combine those terms. So we've got the cosine of 21 pi over 18. We can factor out a 3. So we just have the cosine of 7 pi over 6, which conveniently is a value that we know. So 7 pi over 6 is in the third quadrant, so cosine's negative, and it's a pi over 6, so it's square root of 3 over 2. Sometimes we'll have a problem like that where we don't know any of the angles, or we have a variable in there. So all we do is do what we did on the last one, just simplify as much as we can. So we have the tangent of 6v. This is the tangent identity. our two angles, and the whole thing is the tangent angle. Some people look at this and go, oh, so we're just looking at the numerator. No, it's the whole thing, because our tangent identity up here is that numerator and that denominator. So our two angles, it's 6v and 4v. For tangent, our sign is the same one as in the numerator. And then we just add those together, and we're left with the tangent of 10v. And that's as simple as we can get it. Now, half angle formulas look like this. The thing is, the plus or minus on the sine and cosine just means that we'll have to determine what the sign is, like that SIGN sign, before we work out the problem. We just need to figure out what quadrant the angle is in. So, for example, if we're looking at 6, our sine of pi over 8 is in the first quadrant, so it's going to be positive. What we want to do with this is try and get this, our sine of pi over 8, into a form that is some angle that we know the values for divided by 2. So here, we can rewrite this as sine of pi over 4 divided by 2. So when we use our formula, we're just going to be substituting pi over 4 in for our a or x or theta or whatever variable your formula sheet gives you. So we know it's going to be positive because it's in the first quadrant, and we have 1 minus cosine of the angle that we're using is this pi over 4. Let's circle that in a different color. All right, so it's 1 minus the cosine of pi over 4 divided by 2. Now we have one trig function to evaluate, and then we have a little bit of simplifying to do. So we have 1 minus square root of 2 over 2, because that's the cosine of pi over 4, divided by 2. So then what we want to do to clean this up a little so we don't have fractions in fractions is multiply by 2 halves. So when we distribute that to the numerator, we end up with 2 minus the square root of 2, and to the denominator it's going to be 4. So when we have a square root of a fraction, that's the same as the square root of the numerator divided by the square root of the denominator. Conveniently, we know what the square root of 4 is. So the sine of pi over 8 is 2 minus the square root of 2 divided by, square root of 2 minus the square root of 2 divided by 2. So our half angle formulas are characterized by our nested square roots, at least the sines and cosines. Let's take a look at tangent with this. Now, tangent, we're going to do this the same way. We're going to write this as it's our tangent of 7 pi over 4 divided by 2. So the angle we're going to be substituting into our formula is 7 pi over 4. Now, there are two different formulas here, and you can use either of them, whichever works better for you, whichever speaks to you for the problem. I want to do the 1 minus cosine of a divided by sine of a. So this will be 1 minus the cosine of 7 pi over 4 divided by the sine of 7 pi over 4. So what we'll have is we substitute 7 pi over 4 in, and we get 1 minus root 2 over 2 divided by negative root 2 over 2. Okay, so to clean this up a little, because 7 pi over 4 is in the fourth quadrant, so cosine's positive, but this negative sign comes from the equation, and sine is negative in there in the fourth quadrant. So what we can do is multiply by 2 halves, again, to deal with our fraction here, or fractions within a fraction. It's one of our options. So we end up with 2 minus the square root of 2 divided by negative square root of 2. Then to get the radical out of the denominator, we need to rationalize. So to do that, we multiply by the conjugate of the denominator, which will just be square root of 2 divided by itself. So when we distribute, we have 2 root 2 for this first term. The second term just becomes 2. So it'll be minus 2 divided by square root of 2 times negative square root of 2 is negative 2. So when we factor out a negative 2, because it's a factor of every term, we end up with, well, negative 2 divided by negative 2 is 1. And then 2 root 2 divided by negative 2 is a negative square root of 2. So that is our exact value. We'd get the same thing if we had used our sine of a divided by 1 plus cosine of a. Please let me know if you have any questions, and thanks for watching.